Hey seniors, today we're going to continue writing systems of equations from words, but today we're going to be focused on graphing them as well. Some of these examples are going to look very similar to the ones that we did earlier in the week, and I did that on purpose because I want to show you the same equations, just kind of in a different way. So remember, whenever I'm writing equations from words, I always want to have a starting point. And my starting point, I'm just going to represent as SP, will be my y-intercept. Okay, my y-intercept. The value that increases, is always going to be my slope. Always going to be my slope. So let's go ahead and jump in. Don't write this example. I'm going to read it to you. I'll tell you what to write. Kivy is thinking about joining a DVD rental service. Netflix costs $5 for a membership, and each video is $1. I'm going to go ahead and underline $5 for a membership, and each video is $1. Those are my key phrases there. Blockbuster costs $3 for the membership and $2 to rent each movie. After how many DVD rentals is the cost the same? So let's go ahead and work just with Netflix. Whenever I write my equations, I always want to write it in the form y equals mx plus b, and where y equals the cost of the membership and movies together. If Netflix costs $5 for a membership, that is never going to change. It's always going to be $5 for the membership. So since it's going to be the same, that could be my starting point. That'll be my y-intercept. If each video is $1, I don't know how many videos I'm going to have that I'm going to rent. So I'm going to accompany 1 with an x, because again, y represents the cost and x represents the amount of the number of movies. Blockbuster costs $3 for the membership and $2 to rent each movie. If it's $3 for the membership, that's going to be a one-time thing. So since it's going to be a constant, it will never change. That will be my starting point. $2 to rent each movie. I don't know how many movies I'm going to rent, so I can go ahead and accompany that with an x. So now that I have my two equations, I need to figure out after how many DVD rentals is the cost the same. I can figure this out by graphing it. And the point on the graph where the lines cross, that's going to be my solution. And that will tell me how many movies to how many costs. So let's work with our first equation first. If I have y equals 1x plus 5, 5 is my y-intercept. I'm going to put a dot on the graph where y is 5. If I have a slope of 1, I go ahead and build my staircase. Up 1 and over 1. Up 1, over 1. In terms of rise over run. Up 1, over 1. I can do this all day long. If I want to extend on this side of the graph, I go down 1 and left 1, which is just the opposite. Down 1, left 1. Down 1, left 1. Down 1, left 1. Keep doing this all day long. Go ahead and draw my line. All right, let's go ahead and graph our second equation to figure out where these lines are going to cross. If my y-intercept is at 3, I'm going to go ahead and put a dot there. I have a slope of 2, so that means I'm going to go up 2 and over 1. Up 2, over 1. Up 2, over 1. Again, if I want to extend on this side of the graph, I go down 2 and over 1. 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 If I go ahead and draw my line, I see that these lines are going to cross. They're going to cross right here at 2, 7. That's where my lines cross. What that means is that 2 and 7 are the only pair of coordinates that I can plug in to the solution to make it true on both for both equations. So that means for every 2 movies I spend, that's going to be $7. And that's going to be the same for Netflix and for Blockbuster. If I rent 2 movies, I'm going to spend $7 for Netflix and for Blockbuster. So that answers my question. After how many DVD rentals is the cost the same? After 2 DVD rentals. Let's do another one. All right. Randy just got his commercial driver's license and is starting a new career as a truck driver. Getting trained and licensed involved a one-time cost of $5. I'm going to go ahead and underline one-time cost of $5. Gas and insurance end up costing him $1 per kilometer. For his first delivery, Randy will get paid $6 plus $3 per kilometer that he drives. He's not getting paid very much. If he drives a certain distance on this delivery, Randy will break even, making back all the money he spent. Write a system to determine the distance he has traveled. So I'm going to go back to this first line. Getting trained and licensed involved a one-time cost of $5. Let's go ahead and write our Y's since we're trying to figure out the distance he has to travel. If it's a one-time cost of $5, that will be my starting point. So I'm just going to represent that as my y-intercept, which is 5. Gas and insurance cost him $1 per kilometer. If I'm trying to figure out how long he has to go, I don't know how far he's traveled yet. So since I don't know how many kilometers he has to travel, I'm going to represent 1 with an X. For his first delivery, Randy will get paid $6 plus $3 per kilometer that he drives. Again, if he's getting paid $6, that's just a one-time fee. It's a one-time allowance of $6 plus $3 per kilometer that he drives. Again, we don't know how many kilometers he drives, so that can always be represented as a variable. I could plug in numbers there to figure out the distance. But again, we're concerned about graphing today. So let's go ahead and graph this first equation. 5 is my y-intercept. I'm going to go ahead and put a dot on the graph where y is 5. If I have a slope of 1, it means I go up 1 and over 1. Up 1 and over 1. All day long. If I want to extend on this side, down 1 and over 1. Down 1 and left 1. Go ahead and draw my line. We've plotted enough points. All right, if I have y equals 3x plus 6, go ahead and put a dot on the graph where y is 6. I'm going to go, if I have a slope of 3, that means I go up 3 and over 1. Up 3 and over 1. Since I've run out of room, I'm going to go the opposite way. Go down 3 and over 1. Down 3 and over 1. Down 3 and over 1. If I draw this, it's going to be a really steep line. But since it does cross, since the lines do cross, the point in which they cross, which is at -1 and 4, that is my solution to this system. So that means that these are the only numbers I can plug in order to make both of these equations true. All right, guys, I think it's going to make most sense if we just go ahead and start practicing this. So let's go ahead and get into it.